Folks, we got a pretty intense video tonight, and so the title is no joke. We're calling it Intense GCFs. Not just GCFs, but intense greatest common factors. It'll certainly be at a level that we have not seen before, I believe. So again, and probably the more technical book title would be Factoring Algebraic Expressions Containing Either Fractional or Negative Exponents. See, the key to a polynomial is that the exponents all have to be positive and they all have to be whole numbers, right? So once you change those whole numbers to fractions, or if you change those positive the positive exponents to negative exponents, it's no longer a polynomial. But that's okay. It's still an algebraic expression. And to you at this point in your math career, you probably don't care. Like, what's the difference between it being a polynomial or just an algebraic expression? Down the road, you'll appreciate that difference a little more, and that's okay. So what are we going to see today? And right out of the gates, we're going to factor something like 4x cubed plus or minus 6x plus 10x to the negative 2. And what's new today is that negative 2. See, once I threw that negative 2 in there, it's no longer a polynomial. And we're going to try to take out a GCF. And we're going to talk about why the GCF is x to the negative 2. Or in this next example here, again, you see some fractional exponents, and that first one's even negative, so it's a double whammy. It's as ugly as they could possibly get. You got negative and fractional exponents, and again, we're going to focus on how to identify the GCF, and that's half the battle is just identifying who is my GCF, and then factoring it out. And kind of, I always think of factoring as unmultiplying. You're reversing that distributive process. So we've kind of talked about these couple of bullets. And I think what I want to highlight is this, what I call my Gcf Ninja Tip. We're just going to continually focus on identifying the smallest exponent. If you can see the smallest exponent, you're already there. You're already on your way to discovering the GCF. So we don't have a lot of small talk here tonight. We're just going to dive right in. So I think you'll agree, every term has an x, right? But what is my GCF? X to the first, x to the second, x to the third. What exactly is it? Well, it always comes down, again, to that smallest exponent. So in this particular case, I'm going to make a note to myself. My GCF is going to be x to the negative 2. Now, when you factor out a GCF, again, remember how we said factoring is the opposite of multiplication? It's like you're undoing the multiplication process, right? So guess what you do when you undo multiplication? You divide. So we're going to divide everybody by x to the negative 2, x to the negative 2, x to the negative 2, and then see what that creates. So there's my GCF. If I subtract exponents, I'm going to get x to the 5th, I'm going to get x to the 3rd, and then I'm going to get 10x to the 0. And that x to the 0 is just a 1, so we don't need to write it. Throw your hands in the air. We are done right there. That is our final answer. Here's one of the coolest things about factoring that I love. Let's say I got doubts. I got some doubts. I'm not feeling super confident about my factoring. If time allows, you can always take this x to the negative 2 and distribute it back in and see if it matches up with the original problem. It's a really easy way to check your answer. Boy, if you thought that one was ugly, check this bear out. Okay, first thing I want you to consider are your coefficients. The biggest number that both coefficients are divisible by is 9. Okay. Now consider the a terms, right? Of those exponents, the smaller exponent is the 1/2. Now consider your b's. The smaller exponent this time is negative 5/3. So there's your GCF. We're going to pull that bear out. 9, a to the 1/2. You could write that as the square root of a. I know some of you are thinking about that. And we got b to the negative 5/3. You're thinking, could I do 1 over the cubed root of b to the 5th? Absolutely. All right, so let's divide by 9, a to the 1/2, b to the negative 5/3. Okay, 27 divided by 9 makes 3. Now I'm going to subtract exponents. Just keep talking yourself through this. Subtract exponents, and that's going to make a to the 4/2, which simplifies to a 2. Right? I'm going to do a little sidebar here. 5/2 minus 1/2 makes 4/2, which makes 2. All right, now let's do the b's. I think you're going to get b to the 0 because negative 5/3 minus negative 5/3 makes 0. Plus, kind of switching colors here on the fly, we got to divide by that same GCF. Got to be consistent, right? 18 divided by 9 makes 2. 1/2 minus 1/2 makes a to the 0. And maybe a little sidebar here. Negative 1/3 minus negative 5/3. Well, that makes negative 1/3 plus 5/3, which makes 4/3. How about that? Okay, so we'll go b to the 4/3. We got a pretty funny colored problem here. And you know what? If I rewrite this just one more time, and today, for today, we're not going to be bothered by having a negative exponent in our final answer. So that b to the negative 5/3 is totally okay. We'll get 3a squared plus 2b to the 4/3. Again, like we said on the previous problem, if you have any doubts, you could take your GCF, distribute it back in to check your answer. But we're in really good shape right here. Now, that Ninja Tip, remember we said the Ninja Tip, you got to identify the smallest exponent, and that's going to tell you who your GCF is, right? If we correctly do that, these exponents here will always be positive, always, okay? If you get a negative exponent in here, that's a red flag that something earlier in the problem went wrong. All right, so here's a problem that gets as hard as we can probably make it. So the GCF is going to be this quantity x plus 1. The only question left is what is the exponent on that quantity? So if you analyze those exponents, the smaller of the two is going to be that negative 3/4, right? So there's your GCF. We're going to factor it out. We're going to divide it out. Yeah, that's a good point there. Anytime we say factor it out, think to yourself, divide it out. All right. Now, so when I divide this first expression by x plus 1 to the negative 3/4, you're gonna be left with this x right here, and then you're gonna technically have the quantity x plus 1 to the 0. And then over here, we'll divide by x plus 1 to the negative 3/4. Little sidebar here, 1/4 minus negative 3/4 makes 4/4, which is a 1. So I'll just have x plus 1 to the first, right? Now, let's see, is there anything I can do to clean that up? Is there anything we can do to clean that up? Well, this whole expression is a 1, right? So x times 1 makes x. And anything to the first power doesn't need parentheses. Now I can combine like terms. And let's see, we're getting real good here with this problem. We're getting our money's worth. So we got x plus 1 to the negative 3/4, combine like terms. And you know what? Let's show off a little bit. Let's rewrite this as 2x plus 1 divided by the quantity x plus 1 to the 3/4, just so we feel good about rewriting that x plus 1 quantity on the denominator. All right, I think we got one more up our sleeves as we try to get used to this real strange process. So we're going to color code these maybe just to help you out. This is your first term. This is your second term. What do those two terms have in common? Well, they both have the quantity x minus 1. Now identify the smaller exponent, which is going to be the negative 1/2. So that makes your GCF. X minus minus 1 to the negative 1/2. All right, let's divide this guy by x minus 1 to the negative 1/2. And then we'll just write that one in as well. Divide. So, okay, if I divide here, I get a 2x, and then I get the quantity x minus 1 to the 0. And then if I divide these guys, I'm going to get 3x minus 1. Now, a little sidebar here. If I take 1/2 and I subtract negative 1/2, that's going to make 2/2, which is 1. All right. I like square brackets. I love square brackets. So let's clean this bear up a touch. Now this whole expression becomes a 1, so 2x times 1 makes 2x. If there's a 1 here, we're just going to go ahead and distribute the 3. So it's going to be 3x minus 3. Combine like terms, you're going to get 5x minus 3. And then let's put this term here in the denominator, and we're going to show off and write it as x, or the square root of x minus 1. How good is that, huh? That's some good looking math right there. So I'll tell you what, some tough GCFs, isn't it? Yeah, some really tough GCFs. But again, like we always say, We're going to keep practicing. We're going to keep practicing. And if you don't get it, we just say, hey, I'm not getting it yet, because eventually we will.